Right now, in the middle of the Pacific Ocean, a wall of warm water is expanding at a pace that's forcing meteorologists to revise their forecasts almost weekly. And the reason I want you watching this closely has nothing to do with what's happening this month. It has everything to do with what's coming this fall and winter. The pattern building right now is on track to become one of the strongest events of its kind ever recorded. And the way it reshapes the weather across the entire United States is going to look almost nothing like what most people expect. Not because it's some exotic, never-before-seen phenomenon. Because the specific way this particular event is shaping up runs counter to the intuition a lot of people have about what a pattern like this usually does. I'm going to walk you through exactly what's happening in the Pacific right now, why forecasters keep revising their outlooks upward in real time, and what it actually means for your region this fall and winter, because the honest answer is more specific and more useful than get ready for something big. And if you want to be here as this pattern continues to develop, subscribe to Nymora Proof before we get into it. Let's go. Let me start with what's actually happening in the ocean right now, because the entire story downstream of this depends on understanding the engine driving it. We're in the middle of a rapidly intensifying El Niño event. As of the most recent data coming in, this one has pushed into what forecasters are now calling Super El Niño territory. Some of the newest model runs suggest it could end up among the strongest events ever recorded. El Niño itself is part of a completely natural, recurring climate cycle centered on the tropical Pacific Ocean. A large stretch of ocean surface warms significantly above normal for months at a time. That's in contrast to its opposite phase, La Niña, when that same stretch of ocean runs cooler than average. What's driving this particular event is a powerful oceanic Kelvin wave, essentially a massive pulse of warm water that surged eastward across the Pacific. That pulse effectively ended a multi-year stretch of La Niña conditions that had been shaping global weather for years beforehand. The latest model data from major forecasting centers, including the European model in the UK's forecasting system, is now showing temperature anomalies exceeding 2 full degrees Celsius above normal across the entire equatorial Pacific region, used to measure these events. That magnitude is squarely consistent with a genuine Super El Niño classification, not just a routine, moderate warm phase. Here's why that ocean temperature number actually matters to you, wherever you live in the country, and this is the part that I think a lot of people miss. When a stretch of ocean this large warms this dramatically, it doesn't just change local weather in the Pacific. It fundamentally alters the pattern of rising and sinking air across an enormous portion of the planet. That shift reaches directly into the jet stream, the fast-moving river of air high in the atmosphere that steers nearly every major weather system across North America. Forecasters have already documented rising motion and lower pressure becoming firmly established over the central and eastern Pacific. That's precisely the signature of an intensifying El Niño reorganizing the broader global circulation pattern around it. So let's talk about what that reorganization has already started doing, because this isn't purely a future forecast. It's showing up in the data right now. Meteorologists tracking this pattern have found that July of this year already produced pressure and temperature patterns across the United States and Canada that closely match what's historically been observed during past strong El Niño events. The August forecast reveals the next phase of that development, as increasing Pacific forcing continues reshaping the jet stream with growing influence heading into fall and winter. Right now, as I'm putting this together, the National Weather Service's own extended forecast discussion describes a broad, persistent upper-level ridge sitting across the southern tier of the country. That ridge is driving the hazardous heat we've been dealing with across the south-central and southeastern U.S. It's paired with an active northern stream flow running from the northern Rockies and plains into the Great Lakes and Northeast. That flow is fueling the repeated rounds of severe storms and flash flooding I've walked you through in recent videos. That's not a coincidence sitting next to the El Niño story. It's an early expression of exactly the split flow pattern this event is expected to amplify as we move deeper into fall. Now here's the part of this story that I think genuinely qualifies as the thing that's going to catch people off guard. It comes down to a piece of counterintuitive physics about how El Niño actually behaves during the cold season, which is different from how a lot of people assume it works. During an El Niño winter, a persistent, strong area of low pressure tends to form in the North Pacific. And here's the mechanism that trips people up. That low pressure system pushes the polar jet stream further north than it normally sits. That sounds on its face like it should mean a colder winter for the northern United States, because you'd expect a stronger, more active jet stream running through a region to bring more cold air with it. It's actually the opposite. Pushing the polar jet stream northward means the coldest Arctic air masses get bottled up farther north, over Canada, more often than they'd otherwise be. Meanwhile, the northern United States and western Canada end up on the milder side of that displaced jet stream, seeing warmer than normal temperatures more consistently through the winter months. Meanwhile, The same overall pattern tends to open a more active storm track running across the southern tier of the country. That's the mechanism behind one of El Niño's most consistent historical fingerprints, wetter than normal conditions across the southern United States during the winter, even as the north runs unusually mild. That's precisely the kind of setup that catches people off guard, because most people's mental model of a huge weather pattern is coming defaults to picturing more cold, more snow, more classic winter severity. What a strong El Niño winter actually tends to deliver for a large swath of the northern U.S. is closer to the opposite, a milder, less consistently cold season. The more dramatic weather impacts shift south instead. And the stronger the El Niño signal, the more forecasters trust that this typical pattern will actually show up cleanly, rather than getting muddied by competing influences. That's exactly why the recent revision of this event toward record strength matters so much for how confidently meteorologists can lean into that outlook. Let me also walk you through the piece of this that I think deserves real attention because of how it connects back to a story I've already covered this season, the ongoing amplification of a split flow pattern. Forecasters are describing this year's evolving setup as an amplified split flow pattern building from late summer into fall and winter. The specific location of peak ocean warming within the Pacific actually determines how effectively this El Niño can bend the jet stream to produce that split. When the warmest water sits centered more in the central Pacific, it acts almost like a more direct hit on the atmospheric flow, generating a stronger wave pattern that reshapes winter weather across all of North America more decisively. When that peak warming instead sits confined further east, the tropical forcing interacts less efficiently with the upper-level winds, producing a comparatively weaker ripple effect. That's part of why some regions, like Europe, have been showing a slower response to this same event than North America has. Understanding exactly where that peak warming settles over the coming weeks is one of the specific details forecasters are watching most closely right now. That's because it's the variable that determines just how sharply the split flow pattern actually locks in once fall arrives. I want to connect this back to a story I've already walked you through this season because I think it's a genuinely useful example of how interconnected all of this actually is. The same Super El Niño driving this jet stream reorganization is also the reason this year's Atlantic hurricane season has been running well below average. No AA zone updated seasonal outlook calls for somewhere between 7 and 13 named storms total, a meaningfully quieter pace than a typical year. That's not a separate, unrelated weather story happening to occur in the same year. It's the same underlying mechanism, the same warm Pacific water reshaping global wind patterns, showing up as suppressed hurricane activity in the Atlantic, and as this jet stream reorganization over North America simultaneously. When you understand El Niño as the actual engine behind both of those stories, the connections between seemingly unrelated headlines this year start making a lot more sense. Now, let me be honest about the uncertainty here, because that's always the responsible way to close out a story built around a seasonal outlook rather than a specific storm on the map. Exactly how strong this El Niño ultimately becomes, and exactly how cleanly the split flow pattern locks in, remain genuinely open questions being refined by forecasters in real time. That's precisely why you're seeing outlooks get revised upward on what amounts to a weekly basis right now. The broad strokes of what a strong El Niño winter tends to look like for North America are well established from decades of historical analog data. Milder conditions across the northern tier, a more active and wetter storm track across the south. But translating strong El Niño into specific city-level forecasts for exactly how much warmer or how much wetter any particular region ends up remains a matter that sharpens considerably as we actually get into the season itself. That's rather than something forecasters can nail down with high confidence for mid-August. Here's the part where I want to bring this back to something genuinely practical, because I don't want to leave you with just an interesting mechanism and no actionable takeaway. If you live in the northern tier of the country, from the Pacific Northwest through the northern Rockies, the northern plains, and into the Great Lakes and interior Northeast, this is worth knowing well before winter actually arrives. The odds are currently favoring a milder, less consistently cold winter than what you might be bracing for by default. That has real practical implications for everything from heating cost planning to how much snow removal budget your local municipality might reasonably plan around. If you live across the southern tier, from the southwest through the Gulf Coast and into the southeast, the historical El Niño pattern points toward an active, wetter storm track becoming more established as we move into the cold season. That's worth factoring into planning around drainage, flood-prone areas, and general storm preparedness heading into fall and winter, on top of whatever your region's normal seasonal risk already looks like. And here's the broader takeaway I think matters most, beyond any single region's specific forecast. A weather pattern this large, driven by an ocean event intensifying toward record strength, doesn't announce itself with a single dramatic headline the way a landfalling hurricane does. It shows up gradually, as a slow reshaping of the entire continent's storm track and temperature pattern over the course of months. That's exactly why it's the kind of story that catches people off guard. There's no single day where the Super El Niño pattern arrives, the way a storm makes landfall. It's already arriving right now in the specific shape of the heat dome and storm track I've been walking you through in recent forecasts, and it's going to keep reshaping the picture gradually enough that a lot of people won't clock the connection between this month's headlines and this winter's overall character until they're looking back on it after the fact. Let me leave you with the single most useful way to think about this going forward. Every time you see a forecast this fall talking about unusual warmth settling into the northern US, or an unusually active wet storm track locking in across the south, that's not a series of disconnected surprises. It's the same Super El Niño story continuing to unfold, piece by piece, exactly the way decades of historical data on strong El Niño events would predict. Understanding that connection now, in August, before any of it has fully arrived, is exactly what turns catching everyone off guard into something you saw coming. Before you go, I want to ask you something, because I think it gets at how differently people actually experience a seasonal pattern shift like this one, depending on where they live. If you're in the northern half of the country, does a milder than usual winter forecast sound like a relief to you? Or does it come with its own set of concerns, whether that's drought risk, reduced mountain snowpack, or something else specific to where you live? And if you're in the south, how are you thinking about an active, wetter storm track heading into the cold season? Drop a comment and tell me, because I think the honest answer says a lot about how differently a single large-scale pattern like this actually lands, depending on which side of the country you're watching it from. If this gave you a clearer, more useful picture of what's actually driving the weather headlines you've been seeing all year, hit that like button. It genuinely helps careful, connected breakdowns like this one reach more people instead of coverage that treats every forecast as an isolated surprise. Subscribe to NIMOR Proof, so you're here as this Super El Niño pattern continues developing through fall and winter, because I'll be tracking exactly how it unfolds and updating you as the picture sharpens. Drop your thoughts in the comments, and I'll see you in the next one.